tema deste painel vai ser o cenário internacional do hidrogênio. E estamos aqui com um palestrante internacional que vai falar sobre este tema, o senhor HEIKO STIEBER, e ele é da SMA SUNBELT.
My name is HEIKO STIEBER. I live in the United States right now and work for SMA SUNBELT. SMA being a inverter company located in Germany. And I would like to talk about tendencies in the global hydrogen market. Green hydrogen and hydrogen market for me right now are the same. I'm mainly talking about the electrolysis, meaning the electrical way of producing hydrogen. My role at SMA SUNBELT, which is a solution provider, is a senior project manager, and I oversee all projects that we do worldwide. So I can give you views onto the tendencies in different countries and what kind of markets we're looking at. First, the greeting from my legal department. I have to say this. This is a sales presentation. I will show products. Doesn't mean that you run out to me and buy these products immediately. So first, a few words on SMA and SMA SUNBELT. SMA founded in 1981, was always looking into energy conversion. Here, the main part was conversion from DC to AC, solar systems feeding into the grid. We have an overall installed base worldwide of over 100 gigawatt of solar inverters, battery inverters, but also projects using hydrogen inverters, which in this case are rectifiers. SMA SUNBELT, as solution provider, being a small group in SMA, has been tasked to develop the hydrogen market from our side, being a small group of people, being very flexible, and being able to adapt, especially to this fast-changing young market. Overall, we have built over 450 megawatt of systems, hybrid systems, battery systems, but also power-to-gas systems. And here we see clear tendencies on the world market with a massive system growth, meaning 2 years ago, we were talking about a big project in a megawatt scale. Now a big project is already in 100 megawatt to gigawatt scale. And here I'm talking about 1 to 2 years development, which is very stressful for the market right now. So let me talk a bit about the power to gas market and how we see it as SMA SUNBELT. When we talk about power to gas, this is all based on hydrogen. Hydrogen as molecule, as atom, is really the basic of every product we have around us. So if we would now like to use hydrogen due to the effect that it is a very dense energy carrier for our electrification or energy supply, we will have to change several things. So if I look at this map, you can see on the left upper hand the power conversion of a solar system. DC is produced, changed into AC, and fed into the AC grid. On the lower hand, you have another power conversion using an electrolyzer. This power conversion will take AC energy, convert it to DC, and feed it into the electrolyzer. On the other hand, we have the reverse process using a fuel cell. The fuel cell uses hydrogen, burns it, produces electricity. So in this case, the power conversion goes into the grid. But right now, we are mainly looking at the electrolysis due to the effect, what I also mentioned, hydrogen being one of the basic molecules we need for all our technical processes and products. We have to kind of like look at the impact of the hydrogen production we have right now. And the impact is clearly a high CO2 emission that we will have to see as pollution right now. If we would like to use more green hydrogen, we have to ensure that there's no CO2 pollution. And right now, for the direct reduction of the pollution, only the electronically way of producing hydrogen is the way known right now. I don't know what process we might invent in the future, but might be better. But I have to look at the possibilities that I have right now to serve to the market. Taking a look at the green line, these are all the off-takers that we see in the market, especially industries that have a high need for hydrogen, refineries for oil, but also refineries for steel. Steel processing needs a high amount of hydrogen. If we take a look further below, here you find ammonia. Ammonia is really the basic for several products. Fertilizer is made out of ammonia. Ammonia also is a byproduct or the product out of hydrogen and makes hydrogen easier transportable. So we have possibilities here to share this energy, which is produced somewhere, and we can send it to somewhere else. But also in industries, you will find a growing hydrogen demand. And here I'm mainly targeting, for example, Amazon and Walmart. They have converted their whole fleet for transportation, ground transportation in their factories to hydrogen, meaning they produce their hydrogen locally in their big stores, and then for their transportation, they can take out the hydrogen, meaning they run CO2 neutral in their production right now. Mobility is one sector that is often being discussed, but I would rather shove this sector more into the future. Because if I want to serve the mobility, I would first need more hydrogen cars. Hydrogen cars could be used in different ways, either using a fuel cell, producing electricity, and now feeding into an electrical motor to drive your car. But we are also investigating the use of hydrogen combustion engines, where we don't use gas or fossil fuels anymore. We use hydrogen to drive our car. Well, as soon as we solve this problem, how to drive a car with hydrogen, we need additional networks, like where do I fuel my car? This all has to be built up. That's why I'm saying this transport sector will become interesting more and more in the next 5 years. One point I'm kind of leaving out is the long-term storage. Hydrogen could be used as a long-term storage, meaning when there's an excess of energy, if this is renewable or due to my production fleet, it is not operating very well at nighttime because the load is very low. I could use now this lack of energy, produce hydrogen, and bring my production in a more efficient manner to produce electricity. These are systems which are being discussed, but again, also here the infrastructure is missing. The electrical grid needs to be extended in this case because we're shoving lots of things that are based on fossil fuels now into the electrical grid. And just consider if you take away all the gas stations and all the energy they sell per day and put it on the electrical grid, I would say it would collapse. Looking at this transition overall, and here I'm using the typical figures. Please don't take these figures so seriously. That's why I'm also saying 2021. Normally, would be a very new report, but in hydrogen, this is already old, and these figures are just a guidance for you to explain where we're going to. So if you take a look at the left figure, the energy consumption that we have and how we handle this energy consumption right now is mainly based on fossil energy resources like coal and oil. If we would now want to change this into a more CO2 neutral behavior, you can see how the electricity demand grows. It's electricity. Now let's go back to transportation. We have highways here in Brazil and we have lots of cars. Now just imagine you take the number of cars times 3. Your highways and roads will be crowded. But right now the electrical distribution sector is looking at all of this a bit different because it is all one way. We have big power production. The power stream goes downhill to the consumer. This is a one-way street. And if we start now with this big amount of electricity from renewables, from hydrogen, from all other resources we have, power flows in the grid will start to turn around. Coming back to the example from the vehicles, meaning we have a one-way street, we get more and more traffic, and we hope to handle this amount of traffic by just saying this one-way street is now a two-way street, but it is still too narrow. If we want to achieve our targets in CO2 reduction till 2050, and these are really high targets, hydrogen has the possibility to reduce the overall CO2 emission by 6%. Why am I naming this slide? Just to give you the understanding of the energy market, because this is also my experience coming from the electrical off-grid market, where I bring energy to remote areas where the people have no energy. Every time I talk with them, they say, I don't need a lot of energy. I just need a radio, maybe a bit of light. A half a year later, the system collapses because he's bought more loads. He's bought a television, a freezer, and all this stuff. The system is too small. But you can change all this very easily, and this is the point that I would like to show on this slide. We can reduce by integrating hydrogen by 60%. If we change our behavior and the voice, we can also reduce the CO2 by 11%. So what I want to point out is hydrogen is not the only solution. We will all have to discover the use of energy in the future. And this is pretty easy. If I take a look at solar, you have to use heavy loads at daytime when the sun is shining. Similar for wind. Wind as a resource, as a green resource, is not always available. I can only extract energy when I have wind. And here I see a big key for the hydrogen systems, because in a long-term storage, this overproduction of the wind farms, which we right now curtail, not use, we throw away the energy, could now be used in storing hydrogen. But this goes together, meaning we have to have this freedom of overproduction of energy to use this free energy and produce cheap hydrogen. And this is highly adapted to our behavior in how we use energy. Using storages just makes it easier for us how we use energy. So that's why storages in the renewable market or with the growing renewables are highly needed. And here I'm talking about storages overall. I don't care if it's hydrogen, if it's electrical storage, maybe it's a mechanical storage. But we have to discover these solutions to be able to not inflict with this new energy behavior into our life. The last point that I see on the market is this massive growing demand. And how are we going to cover this demand right now? As I said, we're right now at a production capacity worldwide of 1 gigawatt almost. If you would now order electrolyzer or a rectifier system from us, my delivery time is round about a year, not to name a month or a week. For the electrolyzer side, we're looking at 2 years right now. So this bottleneck will be the main challenge for the future. The only possibility that I see here is changing this market into a scalable and standardized market. Right now, green hydrogen systems or electrical hydrogen systems are all custom tailored. The customer has a certain need. We have a product and another product. We have to put these together with a high engineering effort. If we start to standardize, having standardized interfaces, everybody can put this together and the market will open up. Also looking at the market right now, if I take a look at the customers, how do they approach such a project? They go to electrolyzer manufacturer. They ask the electrolyzer manufacturer, please give me green hydrogen. But that's not all. He needs the rectifier, he needs electrical grid, he needs some kind of pressurizing system if he wants to store the hydrogen. So all these points right now are not standardized. High amount of engineering, and we have to get this out of the system. But I also see a high amount of saving potential on the electrolyzer side, because right now this production process is very new and very intensive. Also here standards are needed. Coming back to the point of the grid and what I would foresee in the future, what is mainly needed inside of the electrical grid to integrate more renewables, but also more storages where we can put the renewable power. Just think of 150 gigawatt, which we will add in the next 10 years as load. I don't know if the production is available to power this 150 gigawatt of power. We have to build this production. And now if we want to have green hydrogen, it has to be renewable. So we are putting the double load now on the grid just with this idea and going upwards with the power massively. So the grid structures have to be renewed, or we have to think about complete different grid structures. If I take a look at the grid development, grids get interconnected. They don't care about borders. But if I take a look at the situation right now in Europe, with a border to Russia and Ukraine, it would have been much better for especially Germany to go into a more independent scheme and not draw so many power lines to the neighbors and ensure that the power production inland is sufficient enough to cover our needs. But not only the electrolyzer capacity has to be built up massively in the next 2 to 3 years, also the systems components, transformers, right now delivery time of over a year for a standard transformer, cables, measurement devices, is all now bottlenecking this fast exploding market. So this is one of the big challenges that I foresee. Just to give you one information, lots of people always ask me about green hydrogen, and they want to couple a PV system directly with the electrolysis and then produce green hydrogen. Right now, the solutions will always need an AC grid in between. And this AC grid has to be powered. We don't see these isolated green hydrogen systems coming up yet, but there's a tendency also here to be seen. With this massive growth of 150 gigawatt of electrolyzer capacity, we also have to look for grid-friendly systems that don't distort the grid, like thyristor-based rectifiers. They bring a high amount of distortion into the grid. With a growing amount of these systems, our grid will get unstable. That's why we only promote the IGBT technology, knowing that this technology has main advantages in grid services. For example, if the grid fails, these rectifiers that we provide, they have fault right through. They will run through the grid fault. A thyristor-based rectifier will switch off. I'm talking about hydrogen production for an industrial off-taker, a refinery, for example, with a steel process in the background. If now my hydrogen production stops, my steel production stops, and I have to run this process up again, maybe over 24 hours. The losses are very high. So we have to take a look at new technologies, how we can serve the market. And here we see that due to our dominance in the PV market, having this experience coupling systems worldwide to the AC grid, we know what we have to look at, and we can also talk with the power distributors and offer functions that ensure that my green hydrogen is only active when the grid also allows that green energy can be put into the grid. So you need a very stable grid to be able to produce green hydrogen. If I now put more production onto it and more load, I will instabilize. So this is a point where we also have to look at. And here, this last point, taking a look at the gigawatt scale, just to give you a feeling when I talk about 150 gigawatt, because it's really the abstract number. The best number I can use here in renewables, PV and wind, Europe has right now installed around about 110 gigawatt of renewable power. This happened over 30 years. We're talking about 150 gigawatt over 10 years. And out of my experience, I grew up in the renewable market, especially in the beginning. This was such a stressful market. We had shortages on modules, we had shortages on cables, on inverters. So this market has to kind of like find a way. And that's why the beginning of these markets is very, very important, that we exchange information and also take away things that people don't understand, like being afraid of solar energy and wind energy, because these windmills turn around, and I don't want to go too deep into that. But the same happens for hydrogen. I see lots of discussions on hydrogen storages. People are getting afraid. Hydrogen bomb, hydrogen, what is it? And now we have green hydrogen. You don't have contact with it. But overall, this is a business that we have to discover, because we're adding another energy source, which is very essential to our overall energy mix. And we know out of our past, only relying on the fossil fuels or on oil is not the idea for the future. Coming to my last point, giving you the information on what kind of reference and what kind of projects we do. I would just like to point out 3 projects, because I see that the time is already running away. Down here, we have a project in New Zealand, which is a 10 megawatt electrolyzer system. This hydrogen was meant to be exported up to Japan for the Olympic Games. Something Corona happened, and there were not a lot of people in Japan for the Olympic Games. So it was a great idea, but it didn't really work out so well. But now this hydrogen is used 100% in New Zealand, only for their own production, for their own steel, for their own ammonia. And so we kind of like turned this around, that New Zealand exports energy cheap to Japan. They burn it, make more money out of it. They're using the system now, keeping their own resource. The sun produces hydrogen. The sun is their own resource, and they can burn it in their own processes. So they're keeping the money inside of the country. Another nice project, Egypt. This is a fertilizer company. Looking at the fertilizer market that we have right now, it is highly impacted by the war of Russia against the Ukraine. This company has a 150 megawatt solar system that on daytime produces electrical energy, where they use this energy to produce hydrogen. on a daily basis. At nighttime, they don't produce, but they store the hydrogen. And then when they need the hydrogen, they take it out in their industrial process to produce fertilizer. Right now, if I take a look at fertilizer production, they produce pretty expensive fertilizer, but they're smart guys. They're selling their fertilizer in bags to big box stores in Europe, CO2 neutral fertilizer. And I've already seen it, and I would be willing to pay the premium of $2 more for this fertilizer because this impact is not so big, but I'm opening up a very big market. The last project I would like to introduce is a project called AirPro. At the beginning, I had severe problems in understanding what he's doing, but he's producing protein heat out of air using water, electrolysis, building up a complex module, a protein, putting some flavor onto it, and he's selling this meat to customers like Amazon, Whole Foods, and here the customer is willing to pay for CO2 neutral protein. So there's lots of market niches that we can now discover which are not really energy related. They are more product related. If I take a look at Brazil with a very big agricultural market, hydrogen could be a great solution for you, not be so much dependent on fertilizer coming from Europe or other countries. Thank you very much. I hope I could give you a good view on, in this short time, onto the hydrogen market, but to be honest, I could talk about this for hours. Thank you.